All right, we are going to go over graphing in science. So, why do we need a graph? Okay, you did this cool experiment. Let's say you decided to count all the M&Ms in M&M bags and see how many colors are in each, and we're going to do multiple bags. All right, if you look over here, somebody did do this. However, this is boring. It also is really hard to tell what's going on. So it takes you a while to figure out, okay, bags are over here, all these colors are here, this is the total, and this is the grand total for everything. So we use graphs in order to show visually what happened from our experiment. For all of our experiments this year, we are going to have data. We're going to graph a lot, we're going to experiment a lot, and grab all this. I am going to have you probably for almost every lab do a graph. Basically, it ends up just being a picture of your data. Okay, we can use bar graphs, circle graphs, or what are also called pie graphs, and line graphs. Most of the time we're going to be using line graphs, but we can use bar and circle graphs also. Okay, so what do we need for a graph? Okay, first of all, if you look at this list over here, we need a title. We need to label our axes. And since we just talked about dependent and independent variables, these are what we're going to graph for our experiments. We need a scale to show what our numbers are. A legend if we have a couple different types of data and want to show the different colors. And we obviously need the data on the graph because no data means nothing cool. So when we go to do a graph, just like we talked about today, we have independent variables, which are the ones we're deciding to change. Okay, these are going to go on your x-axis. So down here is your independent. And on our y-axis goes our dependent. Okay, so every time you do a graph, your independent for our lab goes on the x, dependent goes on the y. All right. When we talk about a scale is just showing the numbers that we got for our data. So for those M&M bags, if we've got from a total of 0 all the way to a total of 50, we need to keep all of those numbers on our graph. Okay, so you need, when you go to do this, this needs to take up the whole area. So if you have this whole area down here, 0 to 50 needs to go from this left side all the way to this right side. Okay, we don't want our whole graph squished up down here because it's really hard to see and it won't look as pretty. Okay, and then same thing with our y-axis. Whatever our y values are from our dependent variables, we need to go from bottom to top. Right, and make them equally spaced. We'll go over this more in class tomorrow. All right, and if you look down here, it says both scales should begin at 0 when possible. Most of the time in what we're doing, we're going to start at 0, but if we don't, we'll go over that and I'll show you what to do. Okay, data. Obviously, in order to show our data, we're using a graph. So if we are doing a line graph, all we're going to do is just plot our points. So if we got number of chapters and number of typos found in a textbook. For chapter 1, we found 2. For chapter 2, there was 4. So you're just going to plot every data point from your data table onto your graph using your independent and dependent variables. Okay, one thing about graphs. When we go to do line graphs, we are never ever going to connect the dots. Okay, we are not in kindergarten anymore, so connecting the dots isn't going to happen. We're going to call this line over here is going to be called our best fit line. Okay, it basically just takes the average of about where all our points are and shows the average trend of our data. So if you look, as speed for this automobile goes up, the cost of the speeding ticket goes up. So obviously not every point here is on the line. Only this one is close and this one's close. Otherwise, if you look, we've got a couple above and a couple below. So that's what it should look like. You should go right through your data with the same amount, about the same amount above as you do below. So best fit line. Okay, sometimes we're going to need bar graphs, sometimes we need line graphs. Most of the time we will need line graphs, but like for that M&M experiment at the beginning, it didn't really make sense to do a line graph when we have certain colors of M&Ms and a number. Okay, usually when we have categories like this that aren't numbers for our independent variables, we're going to use a bar graph. So in this case, this looks really cool. You can tell exactly how many yellows were in this bag, how many blues, how many browns. There are obviously a lot more yellows than there were browns, which was much harder to tell in that data table. Okay, and if you look over here, this line graph doesn't do it as well. Okay, so there's sometimes we want to use a bar graph, sometimes we want to use a line graph. And for our last type of graph, this is what was earlier called a circle graph, or you've also heard pie graph before. So this is usually when we have like one whole set of something and want to show the percentages that make it up. So in this case, for an entire bag of M&Ms, how many are green? How many are blue? All right, and that'll give us an idea visually of how much makes it up. So obviously, you can tell right away that there's a lot more blue in this bag than there was any other color, even if there were no numbers here, because you can tell by the size of the pie chart. All right, so we're just using graphs for data visualization and make them much easier to tell exactly what you found from your important experiment that you were trying to figure out.